Okay, so I call this the AC method, and here's why. Because any quadratic will look like this. It'll look like something, some number a times x squared plus some number b times x plus c. That's what this looks like, right?
Mm-hmm.
There's that. A x squared plus b x plus c. If we write it in order, x squared first, x next, and then just the number, we can always call them in order a, b, and c. That's only though if you write them in order. X squared first, x next, and the number last.
C.
Okay? So that's how you can write them a, b, and c. So a is 2, b is 13, and c is 15. And here's why I call it the AC method. The first thing you're going to do is take a and multiply it by c. What's a?
2x squared.
No, a is just the number that you're multiplying by x squared.
2.
2. What's c?
15.
So what is a times c?
30.
30. Right, that's the first part of it. The next part of it is, I'm going to write right here, b. So we have a, b, and c. In the top we have a times c, and here we just have whatever b is. What's b?
13.
There it is, 13. Okay? This might sound familiar to you. What we're going to try and find are, this is why there's these two regions here, two numbers that multiply to 30 and add to 13. What we do with those numbers is going to be different. So, what's that? 10?
Yeah.
Just the number 10?
I don't think I understood the question.
Okay, here's what we're looking for. Two numbers, one's going to go right here, one's going to go right here, that multiply to 30, and when you add them together, you get 13. These two numbers, they multiply to 30, and they add to get 13.
10 and 3.
10 and 3.
15 and 2.
15 and 2 add to 17.
Oh, never mind.
Sometimes our brains like take 15 minus 2. But we don't want either one to be negative, right? Because we want a positive 30. Unless they're both negative, but then we could get a positive number when we add them. There's definitely just the one combination, 10 and 3. Okay. Here's what you really got to pay attention to. This 10 and 3 usually is like the numbers we're looking for to put inside parentheses. These are not going inside parentheses. What we're going to do with the 10 and the 3 is they're really 10x and 3x, right? Because 10x plus 3x is 13x,
C.
right? And so, look at that. So we're going to break up that 13x. We're going to do 2x squared plus 10x plus 3x plus 15. 2x squared plus, why can't I just write 10x plus 3x? Is that the same as what I have written here?
No. No.
Is it equivalent to what I have written up here?
No, because you're missing out on 15.
Still got 2x squared, we still got
It is.
15x, or
No,
just
I
15.
didn't.
And if I add 10x plus 3x, what do I get? 13x.
I was saying if you like left out 15, like on the second one.
Oh, if you left out 15.
Yeah. Like,
All right, see what we've done so far? We took the 13, broke it into 10 plus 3. Okay. We had to do all that work to figure out that it's 10 and 3 that we're going to add together to get 13x, because we could have done 9 and 4. Those wouldn't work. We could have done 12 and 1. That's not going to work. It's a specific combination of 10x and 3x. And in case you're curious, if I wrote plus 3x plus 10x, it would be the same. Still going to work. All right. You with me so far? Okay. I promise this is better in general than just guessing and checking. Right? It's going to take much less time as you get more practiced. Okay. By the way, if I couldn't have found two numbers that multiply to 30 and add to 13, if it was impossible, just couldn't do it, I would already know that this is impossible to factor. Like, it's just as factored as it can be. Where to go? Okay, there's a nice thing. With the guessing and checking, you would have had to guess and check every single combination, and none of them would have worked. And only then would you know that it can't be factored. Just this part right here tells you it can or cannot be factored. I know it can be factored, so we're going to continue on factoring it. Okay. So that's the AC part. That's right, AC part. Okay. So now we're going to group. We're going to make two groups. Two groups of two things. Here's a group right here. There's one of the groups. Here's the other group. Okay. I'm using circles on purpose. I'm not putting parentheses because parentheses can be confusing. It can be real confusing. So I'm just circling them to get you to just to look at them. Look at them as two groups. In fact, I just thought of this. I'm going to use highlighter. Highlighter is cool. That's terrible.
They're using a break.
just highlighting that group of 2, that group of 2. Right? That whole thing we talked about at the beginning, how I factored out the x plus 3, the entire parentheses, that's where this is going to come in. We look at this group and we ask ourselves, in this group of 2, what can we factor out of both of them? What did they both have in common? They have an x in common. Anything else they have in common?
2x.
These 2 guys have in common. They have a 2x. Like altogether, 2 and x. We can take out a 2x. 2x. Okay. If I factor that 2x out of these 2, we're completely ignoring this, by the way, for just a second. This one is red. 2x times. Okay, what we go in here? If I factor a 2x from both of these, it'll come out to be what?
There'd be an x plus 5.
X plus 5. Okay, so we know that's correct because if we take 2x and multiply by x, we get 2x squared. 2x times 5 is 10x. So far so good?
Yeah.
Okay. Let me change the color of this. I like when things are color coded. No. Can't even see that. Can't see that either. Ah, that works. All right, this group, we're going to do the same thing to this group. What do the terms in this group have in common? What do 3x and 15 have in common?
3.
3, right? This one doesn't have an x. So
Yeah,
it won't
so
have
it'd
x.
just be 3
Just
on
a
the
3.
outside.
So we factor out a 3 from this group, we get x plus 5.
Yep.
3 times x is 3x, 3 times 5, 15. Right? What do you notice about these 2?
They're just distributed.
What do you notice about this parentheses?
They're,
This
oh,
parentheses?
those 2 are the same.
They're the same. It's like,
Oh, so you, okay, I see the pair.
so it's like we're looking at, let's go all the way back to that first thing we were looking at. Remember how I kept talking about this until you were bored to tears? Remember that? How we distributed the x plus 3 to the x and the x plus 3 to the 4, and we got x times x plus 3 and 4 times x plus 3? And I said, can you imagine if we reversed that, what that would look like? If we just took the x plus 3, factored it off of the of this term and this term, and it came back out of the parentheses, and look at that, we would have x plus 3 times x plus 4. Remember all that? Well, that's what we have. It's the situation we have right now in the problem that we're working on, right here. It's like I had an x plus 5.
And then 2x plus 3.
It's like I had an x plus 5 and a parentheses of 2x plus 3.
Okay.
And I distributed the x plus 5 to the 2x. 2x times x plus 5. And like I distributed the x plus 5 to the 3. 3 times x plus 5. I just undid that. And now it's factored, and we're done. It's all over. Right? We made it out. You guys see the movie The Mist?
Yes.
Gosh.
Which is your favorite alternate ending?
I haven't seen the alternate
There's
endings. The one that it has is not my favorite.
where everyone dies except for the dad.
So x plus 5, if I were to distribute it, this is exactly what I would get. Okay? So from here to there, what I'm doing is factoring the x plus 5 from this term and this term, and just taking it outside the parentheses.
Yes.
The thing that I don't want this to look like it's just magic, like this thing floats over there and these guys float over there. That's not what it is. We're factoring out a common factor. They both have a factor of x plus 5. It's just the reverse of what we did at the very beginning of class. Just the very reverse of that. And bring it back down to here. Shelby,
Can I try to crack it?
you wanna do another one, you mean?
Yes. On the pad. You would. So if I get like wrong, you guys can yell at me right away.
Soon for like
That's always
the
a
average
privilege.
person.
So that's
Not soon for one, it's soon for the average person.
I'm yelling at you right away.
Do it. I don't care.
So much more to them.
Okay, so we should have this written down. And right now, what we should do
Like Parsons did last
is, if it's possible, if you can think of them, ask any questions that you have about anything that happened there. Yeah.
How do you get x plus 5, like the parentheses in 2x plus 3, whenever 2x, like if you distribute it? I don't know how it exercises
Right, so let me go back to that first slide of the day. First slide is back there. Okay, remember that, right? And I showed you that the very original way that we multiplied these together was to distribute the entire parentheses to both things, right?
Yeah.
Okay. So we got x times x plus 3 and 4 times x plus 3. Right? So when I go to the other page in just a second, all we're doing is starting from this step and backing up to this one.
Oh, okay.
Okay? So you see from here to there, what I do is take x plus 3 times x and x plus 3 times 4, and they each get their own x plus 3.
Okay.
From here to there, what I would call it is factoring out the x plus 3 from that term and that term, and taking it out. Like if I put parentheses around this whole thing, maybe that sometimes helps. I'm taking this guy, I'm undistributing it. I'm taking this guy as well, I'm distributing it. And what do I wind up with? I wind up with the first step here.
Okay.
It's exactly what we do on the page we were just on. If I were to use the double distribution approach, I would take x plus 5 times 2x, there's 2x times x plus 5. I would take the x plus 5 times 3, there's 3 times x plus 5. And to go from here to there, I'm just reversing that distribution. And I'm factoring out the x plus 5 from there and there. Here it comes outside the parentheses. And if I were to put this in parentheses, here a factor of x plus 5 comes from both of them. I'm undistributing it from that. I get 2x plus 3 left there. Other questions? Oh, if this is a little it's the same. Yeah.
I don't know. I just thought in my head I was gonna show something I didn't make it here with
All right, let me, no more delaying. Let me pull up the next example. While I do this other thing. Okay, give that one a try.
Okay.
So first thing, this is why I call it the AC method, because up here goes A times C. What is A?
30. Oh, multiply 30.
What's A?
Eight.
A is 5, what's C? Negative 6. Negative 30. Okay, and down here goes B. This is the same every time. Like I can make this a sticker, print out a bunch of them, make a little sticker that has a little cross, and AC there, and B there. That is going to be the same every single time. AC goes on the top, B goes on the bottom. 13 right there. Okay, this is where you have to pay close attention. It needs to multiply, not to 30, to negative 30. It needs to multiply to negative 30 and add to 13. Ashley.
15 and negative
15. Negative 2. Okay, so we invested a few seconds. Once you know this method and can do it easily, this takes up a few seconds of your life. And we've done it all to find 15 and negative 2. 15 and negative 2. What do we do with that 15 and negative 2? What do we do now that we know 15 and negative 2 are the magic numbers that we wanted?
You apply them.
We multiply them?
No, apply them to the
To
problem. You're
here.
gonna put them in between. Okay, guys, stop. I'm trying to talk, and it's really pissing me off.
Oh, I hear.
Okay, 5x
Johnny.
squared, and then you're gonna do plus 15x minus 2x.
Uh-huh.
And
And
then
minus 6.
minus 6, yes, there's
Alright.
your problem. And you do
Now.
the highlighter thingy.
Yeah, we're gonna okay, we're gonna erase it. Highlight, okay. The first group of 2. The second group of 2. Okay, and now we concentrate on the first group of 2. What does this first group of 2 have in common in both terms? What do these two terms have in common?
5x.
5x. 5x comes out.
X plus
Factor 5x, we got x plus 3, double check. 5x times x is 5x squared. 5x times 3, 15x. All right, we did that right. Now we ignore this. We just forget it exists for just a second. And we look at the second group. It's highlighted in pink.
Got it.
Now here's a little thing. If I'm looking at this group, and the first number is negative,
You know it's
the
gonna
number
be.
I factor out it should be negative.
Yeah.
Factor negative out. Factor negative out. So what can I factor out of both of these?
Negative 2.
Negative 2. Factor out the -2. That leaves us with, I know it has to be x plus 3 because these two have to be identical because I'm about to try and factor it out of both. And if they're not identical, then they can't be factored out. So we have, x plus 3, right? -2 times x is -2x. -2 times 3 is -6. And we're so close, we're one step away. Kaylee?
You have to like guess for the numbers 15 and -2, right?
Yeah, there's a little bit of guessing and checking there, right? But far less than they are. That part is a little bit guessing.
And then
So then,
final two pairs. One's already in parentheses both ways for you, so x plus 3.
right, we're now, let me just point this out. I realize that. This next, like the answer is going to be x plus 3 times 5x minus 2. I really want you to understand the math behind it. If you were to just take x plus 3 and write it there, not really knowing why you're doing it, and then write 5x minus 2 in the other parentheses, like, your answer is going to be correct, and it's exactly like somebody else who does it for the math reason. I really want you to understand the math reason. That's why we've done it the way that we have. Right? It goes all the way back to that first slide that we did at the beginning of class, that original double distribution approach. Okay, we're just undoing the first step of the double distribution. This has a factor of x plus 3, and so does this. It's like an x plus 3 got distributed to a 5x and a -2. So we're going to undistribute that factor of x plus 3. Bring it outside the parentheses. And the next step is what that looks like once it's factored out.
Is 5x minus 2.
Well, I'll put the x
Or
plus
x plus
3
3.
here, because here it's getting factored out. Okay,
And 5x times
5x minus 2.
2. I got it.
Now, if you have 5x minus 2 times x plus 3, it's the same. It's absolutely the same.
I feel really confident on this. Can I try one?
Well, let's all try the next one, and if you've got it by the time it's time for everybody to come back together, then you can do the inverse of that.
Okay.
Actually, wait. That's what actually should be good.
What? Well, you told me I could do the second to last.
You did.
You totally did. I've got 3 witnesses.
I heard it.
I did.
That's okay.
Oh, there's another one, but I still heard it. Okay.
She can do this one.
Are you sure?
What was the next one?
Okay.
I'll be getting the dab here.
All right. Let's do this one. If you want to use the guessing and checking, it's fine. You can use that. Just telling you, like we already looked at this one, 16 different possibilities. And if you're unlucky enough to guess only the right one at the 16th try, it's gonna be so sad. But if you follow along with me, I promise you're gonna practice. It's gonna be faster. For one thing, I'm gonna find out if it's not factorable at all, like almost immediately. I'm gonna have evidence that it's not factorable if that's the case.
What's the crap?
All right, Swift thumb. I can figure that a lot faster than
Can't be as good as me.
guessing and checking.
Okay. So. I got 144 up here.
Nice.
Wait a minute.
And
Not
I got
quite right.
You're already low.
What?
No way.
Nuh-uh.
That's what I got. Did you just
Seriously.
say I won?
Just take one. Another look at this. Oh.
That Rainy that said that to me. Dude.
What?
I think you should do it.
Negative.
I thought Rainy turned and looked at me at first.
Did it right.
Why is it?
I don't know why
I
you did.
can't do this.
Hey.
Oh.
I like those boots.
I don't want it.
Hey, I see a lot of people who say
Seriously?
that this is hard, but they're not trying. They're just talking.
Yeah, I don't know where it is.
Right.
Thanks, bro.
Please concentrate right up here.
I'm confident.
She'll be showing us how it's done. You got a little something right there.
What? What? Oh, yeah.
There you go.
Eh. So I'm gonna just. That says it all.
All right, so just kind of put a little bit of division between those two groups.
Dude. Oh wait, never mind. How do I? do the eraser thing?
Look on that pen, the top little rocker button, closest to the,
Okay.
press it while you got the pen, and it'll turn into an eraser. There you go.
Ooh,
Now
fancy.
press the other part of that button,
Alright,
and you get the pen back.
amazing, okay. Dude, guys, seriously,
So
I'm.
Shelby is looking for, what do these two terms have in common? She's about to factor that thing out. What do these two have in common?
Oh, God.
Try and beat Shelby to it. A what?
Both got an X.
They both got an X. Also,
Divisible by 3.
divisible by 3. So we take out a 3, and we take out an X.
Dude, Rainy, I'm super mad. These guys won't stop no matter what I'm
I'm
saying.
super mad every day.
I would. Yeah. I'm not
Never hear
actually.
me saying that kind of stuff. Alright, so we got the 3x. As she continues to write, I'm just going to point out 3x times 2x is 6x squared. 3x times negative 3 is me. Take out a positive 8 from both of those.
Rainy, what the heck? No, you're not. You were sorry. You would have stopped 10 minutes ago.
Trying to think.
It's Cinder here. I'm not afraid of you.
He's done now.
It's done though. Okay.
Been waiting.
Thank you, Shelby, for a masterful display of the AC method.
Wonderful.
Okay.
Don't ask to pay attention to you.
Thank you.
I didn't see that.
Yeah.
I love it.
Well,
I tried to.
teaching son. So, would you like Shelby? We'll be in good shape. Now, Shelby, how long did it take you to figure out the negative 9 and the 16? A few tries?
2.
2 tries?
2 tries.
Actually, Shelby was lucky. There's a little bit of luck involved with figuring these two numbers out, especially when this number is so
It's all stupid.
factorable. So very factorable. It has so many factors in it, right?
Mm-hmm.
So many factors. It's 12 times 12, it's 3 times 4 times 3 times 4, which is 3 times 2 times 2 times 3 times 2 times 2. There's so many different combinations. And to figure out that it's 9 and 16, well, we're a little bit lucky. But as soon as we figure it out, we know right away, first of all, that it's factorable. We're going to factor it. If we were to just try the guessing and checking method from the beginning, we just try and run through all the different possibilities we would have. If I even have time to do it. Okay, there's a lot of them. Here's all the ways that I could try and factor just by guessing and checking 6x squared plus 7x minus 24. Just using 6 and negative 24. It could be, I'm going to say 2x, let's say plus 6 times 3x minus 4. Okay, so this is just going to be all the possibilities where I decide on 2x and 3x and the numbers 6 and 4. The 6 and the 4 can switch places, the signs can be switched. Okay, so now I'll switch the signs. So we got 2x minus 6 and 3x plus 4. Okay, well that gives me 6x squared and that gives me negative 24, and it's just left to check, right? This is the checking part. If I get a 7x right there. Oh, I'm gonna have to try it out. Well, then maybe I'll try 2x and a positive 4, and a 3x minus 6. But it could be 2x minus 4, and 3x plus 6. Alright? So that's 4 different possibilities that I would have to guess and check, just based on this being 2 and this being 3, this being 6 and this being 4. I can switch the 6 and the 4, I can switch the signs around, and that gives me 4 different possibilities, just having decided on a couple of things, that I'd use 2x times 3x and a 6 times a 4 to get 24. Okay, well those some possibilities. Okay. I could stay with the 2x and the 3x, but use a different factorization of 24, maybe 8 and 3. So I'll try 8 and negative 3. Okay? And I'm not going to write all these because I don't even want to make you sit through all that, but I could do 2x minus 8 and 3x plus 3. I can do 2x plus 3 and 3x minus 8. I can do 2x minus 3 and 3x plus 8. Like every time I decide on a new factorization of 24, I have 4 more possibilities. Okay, here's another. Let's take another go at it. Maybe it's 2x and 3x, and I use 12 and 2, plus 12 minus 2. Well, then the rest of these would be filled in with using 2x and 3x, but switching around the 12 and the 2, the positive and the negative. That's 4 more combinations.
I understand you can switch the numbers and the signs, and
Yeah.
you're just gonna get more jumped up.
Jumped up to, yeah,
Yeah.
to no end.
I understand your method is a lot faster than doing it.
Hey, you already believe this, so I'm just going to write down one more. This would be if I use 24 and negative 1. Then I could, that's just for 24. Then I could switch it around and make it 6x times 1x, and I do it all over again. So actually I wind up with, that's 6. So I wind up with 32. How do I discount that? I wind up with 32 possibilities. Okay? It's crazy. It's a lot. So, just trying to help you out. Teach you a new method. So that's 32 possibilities for this factorization.
I do not have time to do her problem.
Ashlyn, you think you can do this?
Yes. Let her do
You
it.
can do this one? The number's a little smaller. So. You want to do a live
Yeah.
working out?
Yeah. I have faith
Like,
in-
do your work right here on the board for everybody? Or no, she's gonna work it out. Okay. While Ashlyn's working on that, let me just point out a couple of things as we're factoring. So, if like step number 1, if step number 1 of this, or any factorization approach is to like multiply A by C, in fact, actually this guy right here, you know what? I was trying to make a point with this in that all of these have something in common. What do all 3 of these have in common?
2 x. No, 2.
That's what I should start with. Sorry.
There we go.
Because that's how we would start this problem. And now it's just x squared plus 3x minus 4. That's factorable the old way, like the old easy way of just figuring out what multiplies a negative 4 and adds to 3. So x plus 4 and x minus 1. So that's that one. I thought it was another example. It was actually an example of when we should factor out a 2 because they all have a factor of 2 in common. Here, what do you think I should factor out of all of these right now? What do you see in front? Even in front of that? A negative. Negative. If there's a negative in front, you should factor out that negative. It's just good advice. X squared plus 3x minus 4. Okay? And now it's negative. Now I just factor this like normal. X plus x plus 4 and x minus 1. We have a negative in front. We want to factor that negative out. So, like step number 0 of every factorization problem is factor out anything they all have in common, including if there's a negative on the front, factor out a negative from all of them. Take the negative out. Makes this part much easier to factor in the negatives taking that. But if there's a negative 3 in common, take the negative 3 out of everything. Okay? A few more minutes.